Servus and welcome to this new video on linear equations into unknowns. This is part of a video series which helps you learn about the most important quantitative concepts for the BBE Entrance Exam. And today we will talk about linear equations into unknowns, and you will learn how to solve entrance exam-like questions. And this is an example. You will find the answer statements either on our website with the solutions or in the very end of this video, so you can try it out yourself. Now we will start with very easy tasks and a few general things. If this is too easy for you, feel free to watch the video on double speed and try to solve the tasks faster than I do in this video. Then you're good to go for the entrance exam. Great, let's start with the very first thing you need to know. When solving linear equations into unknowns, we take in general three easy steps. First of all, we compare the equations. When you compare the equations, you can spot how they behave relative to each other, and based on that you can choose the correct solution method. Well, there is no correct or false solution method, but in many cases there is an easy solution method for a given set of equations and one that's not so easy. And because we want to be fast during the entrance exam, it's important to choose the easy one, the one where you can solve everything in the fastest way. This is something I will show you in the next steps. In the end, once you chose the solution method and calculated everything, once you have simplified and isolated the variables, you once again have to check the solutions. During the entrance exam, there's not enough time for that in most cases, but now this is the best practice to plug in the variables you calculated and check if the equations are true. In general, your set of linear equations can lead to one of these solution cases. The very first case is that you have two linear equations which have distinct, which means different slopes. Therefore, they intersect at a specific point and they have one unique solution. In the second case, your linear equations have the same slope, represented by m. This leads to the case that the lines are parallel, and if their y-axis intercept is different, they have no distinct solution because they intercept at no point across the whole number line. In the third case, you can see that the lines have the same slope and the same y-axis intercept. In most cases, this is represented not by the very same equation, but by the fact that one equation is a multiple of the other one, which is represented by the coefficient a on both sides. And therefore, because these lines are identical, they have infinitely many solutions. Let's start with our first example. In this situation, we need to find the solution for the unknown variables p and q in the following system of equations. As I told you in the beginning, we basically have two options. Either we go with the substitution method, where we rearrange for one variable and then plug the rearranged equation into the other equation, or we use the elimination method. And the elimination method is the one we will apply in this case, because upon inspection, you will see that the elimination method is way easier in this particular example. Now I will explain you why. What you try in the elimination method is to combine terms in a way they cancel out, meaning that as we have two unknown variables, p and q, we try to add these two equations together in a way that either p or q cancels out with the one from the lower equation. This basically means that we need to add the both left-hand sides together of both equations and the both right-hand sides. In the elimination method, we add together the first equation with the second equation. How do we do that? we take the left-hand side of the first equation and add it to the left-hand side of the second equation. Then we can see that the terms with p cancel out. The only unknown that's left over in our expression is p. And with only one unknown, as we talked about in the prior videos of this video series, we can simply rearrange for a solution. What you need to keep in mind is that you also need to add the right-hand side terms together, as you can see here. So, we said that the terms covering q will cancel out. This is very obvious because they have a different sign, but the same coefficient and the same variable. Therefore, the only thing that is left is 2/3 times p plus 1/3 times p equals 3, as you can see here. Therefore, if we just add these fractions together, we obtain p equals 3. And this is the easiest way we can calculate one unknown variable in this particular case. Once we have calculated p, we can plug it into the first or the second equation. It does not really matter. You can choose whatever is easier for you. In this particular case, we chose the first equation and plugged in p equals 3. We then calculate 2/3 times 3, which basically cancels out, and therefore 2 plus 1/6 times q equals 2 remains. We then take 2 to the other side, and therefore we obtain 1/6 times q equals 0. Because 6 times q and 6 times 0, if we take this as a step for simplification, yields q equals 0, we have the second variable, the second unknown variable calculated as well. So now we basically got our solution. These two equations hold true if p equals 3 and q equals 0. As you can see, we can solve this example on one sheet in 2 lines. Now we will go to the substitution method just for the sake of demonstration. The substitution method for this particular example is way more difficult. Therefore, it's very important to choose the correct solution method to save time later on. When dealing with the substitution method, we tried to rearrange one of both equations in a way that one unknown variable is alone on the left-hand side. This way, we can take this variable and plug into the original equation. As p is now the only unknown variable in this particular expression, we can simplify and rearrange this one in order to calculate p. After we are finished calculating p, we can use it and plug it into one of our initial equations. Or if we want to have it a little bit easier, we can directly plug it into the formula we obtained before, which is noted right here. Once we plugged p into this formula, we can then again simplify the expression and calculate q. As you can see, q equals 0, just like in the elimination method. Right here, check. This fits, and let's check for p. P equals 3 in the elimination method and also in the substitution method. In general, it's important that no matter what solution method you're using, both yield the same result. And this is also a way you can check if you did everything correctly. In the very end, you can once again use q equals 0 and p equals 3 and plug it into the original equations. Plug it into one of these and try if the left-hand side and the right-hand side matches. If it matches, then we have a proper solution. If it doesn't, we made a mistake and need to revise our calculations. I won't do it for the sake of time, and now we will go to the second set of equations. In this example, we once again have to calculate the solution for the following system of equations. Now, we first of all start with the inspection method and try to determine which solution method is the easier way to go. What's your guess? Is it the substitution method or the elimination method? Observe that the left-hand side of the second equation is exactly the double like the left-hand side on the first equation, which basically means if we multiply the first equation by 2, we obtain the very same left-hand side. However, note that the right-hand side, which is in this case 6 times 2, 12, is not the same like the right-hand side for the second equation. This discrepancy signals that there is no point in u and the v that satisfies both equations simultaneously, and therefore there is no need in starting the elimination method or the substitution method at all. As these both left-hand sides are equal but the right-hand sides differ, we have the second case like we talked about in the beginning. We have two parallel lines which will never intersect because they have the same slope but a different y-intercept. And therefore we can conclude that this particular system of equations has no solution. In example 5.10, we once again have a special situation. When trying to calculate the solution for the following system of equations, after taking the very first step, the step of visual inspection, you will probably see a very interesting fact. Which one is it? The very first equation is exactly the double of the second equation. And therefore, because both the left-hand side and the right-hand side were multiplying by 2 obtains the second equation, we can conclude that these equations both have the same slope and the same y-intercept. How many solutions do we have in this case? When navigating back to the thing we talked about in the very beginning, the three solution cases, in a case where one equation is simply a scaled variation of the other equation, we have infinitely many solutions because the lines lie upon each other, above each other, and they intersect at each single point. When using the elimination or substitution method, you would obtain a solution which in general is true. For example, 0 equals 0. Because both sides of the equation are the same, the expression is true. You could experience it with any number. For example, if you have a variable a equals a, this is also a true expression, and this is your hint that you are dealing with a system of equations with infinitely many solutions. In the case when you obtain, for example, a equals b, we have a false expression. And a false expression would indicate something like we had before, in this case, where we have two parallel lines which never intersect. But if they intersect in every single point, like in our case, we would have something like this. As you can see, you don't always have to calculate something using the substitution or elimination method. It's absolutely sufficient in some cases that you just use visual inspection to actually get to a solution. And this way you're much faster than writing everything down and performing all these difficult steps when calculating the solution. Because we want to be fast, the best approach is to use visual inspection to see how these solutions, how these equations behave relative to each other before going on. But in many cases in the BBE entrance exam, you will encounter something like the text problem. a problem where you first need to come up with a system of equations by yourself and then solve them afterwards. This is what we will do in this example. To create a system of equations, we first need to understand the task. Therefore, let's read through it together. A farmer has chickens and cows. The animals on the farm have a total of 50 heads and 140 legs. How many chickens and cows are there? In general, it's very easy to answer those because both animals have only one head each. And then you need to differentiate. A chicken has 2 legs and a cow, of course, has 4 legs in most cases. So let's define a variable for chickens and for cows. Let's say that chickens are represented by X and cows are represented by Y. We need to remember this information and turn it into a system of equations. As we said, both animals have one head each. Therefore, 1x plus 1y equals 50 heads. So, this one is done, and the other equation is that 2x, which represents 2 legs per chicken, plus 4y, which is 4 legs per cow, equals 140 legs in total. Now we can choose either the elimination or the substitution method once again. In this particular case, neither one is the better option. It doesn't really matter which one you choose. We will go for the substitution method. Therefore, we solve for y, meaning that we take this equation and rearrange for y by subtracting x from both sides. This way we obtain y equals 50 minus x. As we calculated the value for y in terms of x now, we want to plug in y into one of our equations. Actually, it would have been easier to input y in this equation, but we inserted it into this one, and now we have to calculate a little bit more. But in the end, both cases obtain the same solution. So, instead of 4y, we write 4 times 50 minus x, which we calculated right here, and then simplify this whole expression. This way, as you can see, it's way more complicated, like if we have inserted it just right here, but this is what we need to deal with now. And yeah, after simplifying everything, just by adding, subtracting, and dividing a little bit, we obtain this expression. Then we simply need to isolate x in order to calculate the value for this unknown variable. Now we take x and plug it back into this expression. I didn't draw it nicely, but 50 minus 30 equals 20, and therefore y equals 20. And we calculated the solution for both our unknown variables, and consequently we calculated the intersection point of our two equations. We're now dealing with the first case right here. Our both lines have distinct slopes, which means the slope of one line is different than the slope of the other line, and both y-intercepts are different as well, and therefore we have one unique solution. In the very end, it makes sense to check if the results actually make sense. If you obtain something like 30.7 chickens, you might have done a mistake because it doesn't make much sense to have 0.7 chickens. Therefore, make sure you plug these values into the original equations once again and see if everything adds up. If it does, nice, you probably did everything correctly, and if not, you should check your calculations once again. Like promised in the very beginning of this video, we want you to get familiar with entrance exam-like tasks, and this is one for linear equations in two unknowns as you might encounter on the BBE Entrance Exam. First of all, you need to start by determining your own system of equations like we just did in the prior task. Then you need to use the substitution or elimination method to calculate the solutions for this system of equations, and then based on that you can determine if these answer statements are either true or false. If you want, you can navigate to our website and compare if your solutions are correct, and if you need any additional help with it, you can also find the step-by-step solutions which show you how to solve this particular task. Of course, if you sign up for the free sample paper, you will not only find more questions about mathematics, you can also dive into some economics or English related questions. I hope this video was helpful for you. And if you want to further your skills, I definitely suggest you check out this playlist, which covers a whole lot of mathematical concepts relevant for the BBE Entrance Exam. You could also go with this video, which helps you to gain deeper insights into what it's actually like studying at WU. See you in the next one.